good day. Welcome back. So today we're on our part 3 of our free body diagrams and formulating the equations of Newton's laws of different objects. So without wasting time, let's just read out our statement so that we take out the important information that will help you to formulate your equations and as well as drawing your free body diagram. So we're having two blocks of mass 5 kg and 2 kg. So like I said, that if you just know that you're having mass, it means that this object will also have what? It will also have Fg. So anything with mass, we have Fg. Are connected by a light inextensible string. So also we know that these objects are connected, so there will be tension there. A force F is applied on the 5 kg at an angle of 20 degrees to the horizontal. So also know that on this object you are also having the force applied. And you can see that this object is on a surface, so it will have normal force as well. So to the horizontal, and the system of the blocks accelerates to the right. So now we know that these objects are going to the right. So this is the direction of motion. The kinetic frictional force on the 5 kg block is 10 newtons. So already we can see that we are also having the frictional force on this object. So this frictional force, it is obvious that it will be going in the opposite direction, because we say that frictional force always goes in the opposite direction of motion. So now our free body diagram according to this object. Now first we draw our dot like that, and you know that our normal force is always perpendicular to the surface. So this will give us our perpendicular like that is our normal force. And you know that gravitational force is always perpendicular downwards. So we can also have our Fg like that. So now our force is at an angle, so we can try to just show an angle like that. So this is our force applied, right? So since these objects are connected by a string, they have tension. So it means that our tension according to this object, since this is the object in front, so it means that our tension will be going to the back. So this is the tension that will be used to pull up the other object. So we can just show that by tension. And you also have frictional force between the surface and the block. So we can represent like that is our frictional force. So these are the forces acting on this object. So this is our free body diagram. And now to formulate our equation of motion, now what can we do now? We know that our equation, we take all the forces that are acting parallel to the motion. So the motion is going that way. So how many forces are parallel to that? We can see that we're having 1, 2. But this force, even if it is not parallel, it is having a component that will be parallel to the motion. That will be parallel to the motion. So we know that if we're having the force that is acting at an angle like that, this force, we have two components, the F at x. We don't draw that on the free body diagram, but however we know that it exists like that. So we just have to know at the back of the mind that it is existing like that. And we also have F at y. So now we'll be having three forces that are acting parallel to the motion of this object. So it is F at x, tension, and force applied. So now how can we formulate our equation now? So equation, we can formulate it. First thing first, we can just say our F net is equivalent to mass by the acceleration. So we're having three forces, which our motion direction, it is to the right. So it means that this force that is going to the right, it will be a positive force, and this force is going to the left, there will be negative forces, right? So, but first we write it as F at X plus tension plus frictional force must be equivalent to MA. And before I forget, let me show you. We know that to find our F at X, we use F cos of theta. And to find our F at Y, we use F sine of theta. Don't forget that. So now, let's show the direction now. So our F at X, which was positive, or which is positive, plus our tension is going to the opposite direction, so it will be negative tension, plus negative frictional force, also going in the opposite direction, must be equivalent to mass by acceleration. So this is our equation of motion of our first object, or block, that is 5 kg. So now let's go to the object that is 2 kg now. Let's see how we can formulate our equation of and our free body diagram as well. So let's see. So we know that this object is not on a surface, so it is not having normal force, but however there's tension. So you can see that we're having tension on this object. Let's just show it. So we're having tension, and we're also having Fg, since it is having mass. So this object is not on a surface, so it is not having frictional force. There's no normal force, and there's no any other force that is applied to this one. So we just have tension and Fg. So now the motion of this object, since this is going to the right, so it means that this one is being pulled up like that. So let's draw a free body diagram. This will only have two forces. So on this block, we are just having the tension, and we're also having the Fg. No matter the situation, Fg always acts downwards. So our equation now of motion of this object, we can just start by saying F net is equal to mass by acceleration. Since this object is going up, so it means that the only forces that are parallel to the motion of this object, it is this and that. So these two forces are parallel to the motion. So now we should show that. So this is tension plus Fg is equivalent to mass by acceleration. So this is going up, which is in the direction of motion, so it is positive. And our Fg is going in the opposite direction of motion, so it should be negative. Fg is equivalent to mass by acceleration. So this is our equation of motion of block B. So if you want to understand this better, please make sure that you've watched our lessons on Newton's law. You can grab this better. So in this playlist that you are watching this, you can check out our lessons on all the forces and also every explanation on Newton's laws. I hope you enjoyed this, and I hope that you gained something. If you have, please show us by a like and a subscription. I'll see you on the next one. Enjoy the rest of the day.